So today we want to talk about the Poisson distribution, which is a very common distribution depicting and describing many processes that's happening in everyday's life. So let's see a simple question that we have, for example. So in the call center of a certain company, an average of 45 calls are accepted every hour, every 60 minutes. And what I'm asking is, what's the probability that exactly 93 calls are accepted in 2 hours? What's the expected value and standard deviation of the calls expected in the call center between 5:30 and 6 p.m.? And in 10 minutes, what's the chance that at least 4 calls are accepted? So we're going to work with basically with these formulas. The first one is the formula that shows the probability for a single event of x of k events exactly happening in a certain time. Here we have the expected value of the Poisson distribution, which is lambda, and here we have the standard deviation of lambda of the Poisson distribution, which is the square root of lambda. So let's see how we approach this. So as for the first question, what's the probability that exactly 93 calls are accepted in 2 hours? So basically, if we're expecting 45 calls in a single hour, in a single 60 minutes hour, so in 2 hours, we're going to expect 90 calls, which is twice 45, right? So this is what we're supposed to work with. So we're going to work basically with that formula. Only we're gonna adapt this to be adequate to 2 hours. So that means, so we're expecting instead of negative 45 for the lambda, we're gonna do negative 90 for the lambda because it's discussing 2 hours. And the lambda, the value of lambda would be 90, and the value of k would be what actually happened, which is 93. So it's going to be here it's going to be 93 factorial. So basically this is what we're looking for, and that'll be the probability. So the number would be this. It's about 4%, right? 0.03933. So that is the probability. This is a 3933. So that is a probability that if we're expecting that is a probability that we're going to get 93 calls in 2 hours. As for the expected value and standard deviation of the calls accepted in the call center between 5:30 and 6 p.m. So basically this is half an hour, right? So we're gonna we'll need to use these formulas. So the expected value would be the half of 45 calls, because 45 calls attribute 60 minutes. So the half of this for 30 minutes we're going to be 22.30. I'm sorry, 22.50. So we're going to be expecting 22.5 calls on average within 30 minutes. And as for the standard deviation, so that needs to be the square root of 22.50, which is 4.743. So this is the standard deviation of expected calls within 30 minutes. Now the next question is, in 10 minutes, what's the chance for at least 4 calls are accepted? So basically what that means is that we need an infinite number of calls, right? We need 4 and 5 and 6 and 7 and 8 and 9 and 10 and so on and so forth. So what we can do about this is actually cancel out what we're not interested in. And what we're not interested in is effectively the probability for 0 or 1 or 2 or 3 calls. So this is what we're not expecting. We're not welcoming, right? So this is what we're going to be looking for. So that'll be 1 minus the probability for x equals 0 plus, sorry, x equals 0 plus probability for x equals 1 plus the probability for x equals 2 and the probability for x equals 3. And we can do something about it to make it a bit quicker. First of all, it discusses 10 minutes. So if in 60 minutes we're going to expect 45 calls, so in 10 minutes we're going to expect 1/6 of 45, right? So that'll be 45 over 6. So we're going to be expecting 7.5 calls within the first 10 minutes or within any 10 minutes. So basically what we need in this case, we need to do that needs to be under parentheses because we want to cancel all these out and remain with the probability for 4 or more. So here what we're going to do, we can use the fact that we're expecting 4 times the exponent to the power of negative 7.5, and here we actually have 4 elements we need to add, right? So we have basically this. So following by this formula, we're going to be doing this. We're going to be doing 7.5 to the power of 0 plus over 0 factorial. And we're going to do the same thing with 1 and 2 and 3. And eventually we're going to get 1 here, 2 here, and 3 here. And we're going to get all these and put that in the Wolfram tool. And the final result is going to be very quick and easy. It's going to be 94%. So that'll be 0.941. So that is 94.1%. And this is how we do these questions in the Poisson distribution.